Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Nightingale by Nicholas Duhale. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. There are 9 doubler cells in the grid, one in every row, column, and box. And each digit from 1 through 9 appears in a doubler cell exactly once. And a doubler cell's value counts as double its digit. So the value of a doubler cell is double its digit. And there's one per every row, column, and box. Along green lines, adjacent values differ by at least 5. So, for example, say we had a 3 here. Then this could be an 8 or a 9. Or it could be a 5, 6, 7, 8, or 9 doubled. Because the values that are 5 or more away from 3 are anything that's 8 and above. Actually, I guess 4 doubled also works too. So any value, any digit 4 or more doubled would also fit. So that's how these green lines work. And I call them Whisper 5 lines because a setter came up with that name of different for the name for a name of this line. And I think it made a lot of sense because it was very easily extensible. Along pink lines, values form a consecutive sequence in any order. So, for example, we could have something like, say, 7, 4 doubled, and 6. Because the values are 6, 7, and 8, which form a consecutive sequence in any order. We could not, though, have a 4 regular with 6 and 7, because 4, 6, and 7 does not form a consecutive sequence. Finally, we have arrows indicate the direction in which the first 3 values in that row or column nearest the arrow increase or decrease. For instance, the value in row 4, column 1 is strictly greater than the value in row 4, column 2, and the value in row 4, column 2 is strictly greater than the value in row 4, column 3. So the arrows indicate in which the first 3 values in the direction in which the first 3 values increase. Or decrease? Huh, that's weird. Okay. What does that... Why is it increase or decrease? It's got to be just increase, right? Because it's a direction that the arrow points to is the direction in which the values increase, at least from the example given, right? Because if it could be increase or decrease, that means you could have row 4, column 3 be greater than row 4, column 2, which would be greater than row 4, column 1 if it's decreasing in that direction. So I think the arrow points to the direction in which the values increase, would be my guess. Because otherwise it makes no sense why you have both. Increase or decrease. And if no arrow appears adjacent to a row or column, the 3 nearest value must not strictly increase or decrease. So that could work here if this value, because it could have 6 and then 9 and then 7. And it's not strictly increasing from one cell to the next. It's increasing from 6 to 9, but then decreasing from 9 to 7. Oh, well, right. And that would be for the first three digits, or sorry, first three cells in each row and column that does not have an arrow. So this is not valid here for that to be the case. But you could have, say this was 8 doubled. And if this was 8 doubled, we could have, say, a 7 here and then a 6 here. And then that would work because there's no arrow next to this row, or next to these 3 digits. And it's increasing from the 6 to the 4 doubled in value, which means it's 8. And then decreasing from the 8 to the 7. So it's not consistently increasing or going one direction or the other direction. Yeah. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, in row 9, along these 3 cells, which are all on a Whisper 5 line, they have to be consistently increasing till going to the right. So that means then one of them is going to have to be double the others. So this is going to have to be a low digit. This is going to have to be a high digit, and this is going to have to be a higher digit, which means it's going to be doubled. So this is the doubler in this box, which means there are no other doublers in this box and row and column. So there's no doublers here. This must be a low digit. What's the highest double we can get? So these have to naturally be 5 apart from each other. So one of them's going to have, this is at minimum 6. Which means this, we could have 7 here, potentially, and then 6 doubled. So this is 6, 7, 8, 9. This is 6, 7, 8, 9. This is 1 through 4. That's not really, actually it could work. 4, 9, and then 8 doubled is 16, or 7 doubles 14. So that does work. This is decreasing from here to here, so this must be greater than that digit, so it's at least 2. And this must be greater than that digit, so it's at least 3. This digit is greater than at least 4 other digits in this box, because it must be, hold up, it's increasing. It's increasing, oops. So it's increasing going this way, it's increasing going this way. So this has to be greater than this digit, which is greater than that. So this must be, this is less than these 2 digits. So no 1, 2 here. This is 2, 3 as possibility, and this is 1 or 2. This must be increasing that way. So this is 3 or 4, which has to be 5 or more away from 8 or 9. This is greater than this digit. 2 through 8 here, and then this is 3 through 9, because this must be greater than that. And we have something similar here in row 1. So that means it must be increasing from these. So these have to be both low. This is the doubler here, which eliminates doublers in the rest of the box and row and column. And again, this is 1 through 4. This is 6 through 9, and this is 6 through 9. It must be increasing from here to here to here. So this has 2 digits greater than it here. So it cannot be 8 or 9. So it's 6 or 7. Um, these have to be greater, so it's at least 7, 8, 8, 9. We have a 6, 7, 8, 9 quadruplet in box 1. That eliminates 6, 7, 8, 9 in the rest of the box. We also have the blank ones, right? So value-wise, this must go up and then down. So this is definitely greater than this in value. Therefore, this must not be greater than this in value. So this has to be less than this one. We cannot have a 5. Well, we could have a 5 here if it goes down and then goes back up. So this, but this digit is 6 or 7. The only digit which is 5 or more away from it, because this is the doubler, has to be less than 3 or 4. So it's 1 or 2. So technically, we could go 2, 1, and then go back up. That is potentially possible. Hmm. Um, this is going up and then down. That's fine. This is going up and then down. That's fine. Um, you could go 7 then 12. That is valid. Hmm. This is going down then up. Up, up. Don't know about this. This is going to be greater than that. Hmm. Um, hmm. Um, hmm. What else do we have here? Oh, this can't be 8 here. If this is 8, that forces this to be 9 to fulfill the arrow. But then that would eliminate all possibilities for that cell there. So no 8 there. This is definitely greater than whatever is here. So then this must be less than whatever is this digit here. Again, you cannot have 8 here because if this is 8, that would force this to be 9. And then this would be not, there would be no value possible there. You could have 1 here. Um, hmm. Is there anything else we have? Ugh. This cannot be 3, because if this is 3, this becomes 2 and 1. But then that would eliminate all possibilities for that cell there. And it can't be 4, because then all 5 of these digits would have to be less than 4 or less. But that's not possible because we have 5 cells there. So no 3 or 4 here. This could be smaller. If this were 5, that would mean we have 5 guaranteed digits smaller than it, because this has to go down from the double digit and then back up because there's no arrow on the outside here. So this cannot be 5 because, again, if there are not 5 digits less than 5 in value in normal Sudoku. So this can't be 5. This is 6, 7, 8, or 9. This is less than that. Sorry, this is greater than that, which is less than that. Hmm. Hmm. So we know this is greater than this, which is greater than that. This is greater than that, which is less than that. This is less than that, which is less than that. Don't know this relationship or this one right now. This can't be a 2. If this is 2, that forces this to be 1, and this digit would be greater than 2. So that's not going to work. What else do we have? Okay, what is this digit? This digit is greater than that, which is greater than that. And these values, well, we can't have more than one digit here that is 4 or less, because we already have 3 digits in the column that are 4 or less. Also, it must be increasing from here to here. So there are at least 4 digits or 3 digits that are guaranteed to be smaller than it. One of these is a digit. So this can never be 1 through 4. It's 5 through 9. We can't even have 5. If we try to have 5 here, that means we'd have to have 2 digits which are 4 or smaller. Obviously, if you double, that makes it even bigger, which is not allowed. So this cannot be 5. It's 6 through 9 there. Okay. This here cannot be a 1 through 4. Because then this would have to be smaller than it. So again, if this is 1 through 4, this would have to be smaller than it, but there are no other digits possible to be because of all the digits remaining in column 7, which we already have 4. We would have 4 guaranteed to be 1 through 4. So this must be 5 through 8, which means this cannot ever be doubled. Because if this were doubled, it would be greater than this value there, which it's not. It has to be less than that value. And this could be 1 through 4 here. This is at most 7. So this is 1 through 7. It can't. It could be 1 double. No. Cannot be 1 ever, because if that's 1 doubled, this would just be too small. Because it'd be 2, 1, 0 as values, which obviously you can't have 0 as a value. So this is at least 1. So it could be 1, 2, 3. So this cell has 4 values greater than it. So this is 5 at most. Right? Because even though these might not all be digits, we have 4 values that are greater than it, and the most this could be is 9. So that 9876 in value. So it's 5 at most in value there. This must be between these 2 in value. This is 7 at most in value. So this is 2 through 6 here. But again, we could have 2 doubled there, so that is a possibility. Oh, interesting. How does this work as a Renban? We know this value is at most 2 greater than this. Therefore, it has to be exactly 2 greater than this. Well, then this is 1 between these, and this is 1 between those. Oh, so that's a similar thing here. Right? This has to be 2, this digit has to be 2 greater than that, because of the way that the arrow works and the way that the Renban works. So these must be the same value. And since they are the same value, one of them has to be the doubler. So we have a doubler here, and these can't be doubler. These can't be doubler. Same here. One of these is doubler, which means this can't be doubler. And these can't be doubler. So these must be odd digits, because the doubler must double up to whichever the other value is, which has to be an even value. So this cannot be 2, 4, or 6. This can't be 2 or 4. So this could be 1. That doesn't work. 1, 2, and 3. Doesn't work because that requires 1 doubled. So can it be 3, 4, 2, and 5? Yes, it could. Or it's 5, 3, 6, and 7. Interesting. So either way, one of these is a 5, which eliminates 5 in the rest of the row and box. So this must be greater than that. So it's either 3 with 4 in value and then 5, or 4 or 5, 6 in value and then 7. Well, either way, 5 is going to be here. Where is 5 in box 1 then? Cannot be here, because if this is 5, that would be greater than that digit. This digit has to be less than this. So 5 has to be here, which means it's increasing from, and that works fine. Okay. Um, hmm. So these must be odd digits here. So we have 1, 3, 5, 7, 3, 5, 7, 9. This can't be 5 because of 5 in the column, which means this can't be 3. Again, we cannot have 1, 2 in value with 3 because that would require a 1 doubled. So we have 5, 6 doubled. Sorry, 5, 6 or 3 with 7. So we're guaranteed one of these is a 7. Or 7, 8 in value. So 4 and 8. Oh, with 9 there. Well, we're guaranteed one of these digits is a 6 or an 8, right? It's either 3, 6 paired or 4, 8 paired. That means this is guaranteed to have a 7 and it's guaranteed to have a 9 here. Well, 9 can only be here, so this is 9. That eliminates 9 here, and this can't be 7 because the 7 is guaranteed here. So the remaining digits in column 2 are 1 through 5. And this can't be 5 because it has to be next to a digit that is 5 or more away. Because neither of these are doubles. Okay, so we're guaranteed 7's there, which means 7 cannot be either of these digits. This has to be 6 through 9 here. To be 5 or more away from 1 through 4. This has to be continuously increasing this way, so this digit must be greater than that. So this is 1 through 4 also. Interesting. And then this must be greater than that. So technically it could be 2 here if it's doubled. There's no 5 because of 5 in the column. We are guaranteed. Where is the 4 in box 1? It has to be one of these two digits. Because again, it cannot be 4 here because that would be decreasing from this cell to this cell to that cell. So there is no 4 here. So if this is a 2-4 pair, this is 2 and that's 4. This is 5 or more away from 1 through 4. So that means even doubled, you could have 3 here. So 3, 4, 6, 7, 8, and 9 there is possible. Okay. This is either 6 or 8 in value. We don't know which. These are the same values, so it's not strictly increasing or decreasing there. Where is 6? We are guaranteed one of these is 6. So it could be 7 with 6 doubled. That does work. 7 and 6 doubled is 12, which is 5 apart from each other. Or it's 6 with 8 doubled here, which also works. Hmm. So where's a 3 in box 3? Either this is 5 with 3 doubled and 6 here and 7, or this is 3 here. So we're guaranteed one of these 3 cells is a 3. Where is the 3 then in row 1? It cannot be here because we have a guaranteed 3 in one of these 3 cells. Can't be here because of the way that the Whisper 5 line works. So 3 is one of those. So 3 has to be one of those 3 digits there. This is continuously increasing going this way. So we have 1 through 7 here, 2 through 8 here, and 3 through 9 there. Technically, it could be 2 doubled also. And then we could have 3 and 1 there. Hmm. Mm-hmm. These are the same values, so this is fine. I have no arrow. Where's 5 in row 1? We're guaranteed a 5 here, so this cannot have 5 there. And we can't have 5 here because it's on a Whisper 5 line. So 5 has to be one of these digits here. Interesting. So we have guaranteed 3 and 5 there. Hmm. 7 has to be one of these 3 digits. Hmm. This value is always a 6. Aha. Sorry, this value is always 6 or 4. So this value can never be smaller than that. right? Because this 6 or 4 is always going to be less than 6, 7, or 8 here. Because we're guaranteed either this is 6 in value with another 6 in value here, which means this can't be 6 in value, or these are 4 in values, which are going to definitely be smaller than 6, 7, or 8. So this can never be 1, 2, or 3. It can't be 4, because if this is 4, that would mean these are 6s in values here, because we either have both 4s in values here or both 6s in values here. And then this would be decreasing from the 6 to the 4, and then from this digit to that. So no 4, it could be 5 through 9 here. And it cannot be 5. Oh. That's interesting. So that means this has to be greater than this, which means it's going to have a 5 in value or higher, but this can't be 5 because of the 5 in the row. So this has to be 6 through 9. If we tried to make this 5, 6, and 7, the problem is we'd have 3 digits, which would have to be greater than 7 when there's only 2 available, right? Because we don't have 5 and 7 available. So this cannot be 5, 6, 7. It has to be 3, 4, and 5. So we know this is 3. This is a 4 in value. And this can't be 4 because of 4 in the row. So this must be 2. This must be 4. That's 2 doubled. So the 4 is not doubled. And this is 5. So 2 and 3 eliminate 2 and 3 in the rest of the row. So no 2, 3 here. It's 4. This can't be 2, 3, or 4. It's 1. 1 eliminates 1 here. So it's 2, which has to be 5 away from 7. That makes this 8. And that forces this to be 6 doubled here. 7 is 5 away from 6 doubled, which is 12. That leaves this as a 3. So 8 eliminates 8 in the rest of the row. No more. This 8 eliminates 8 in the rest of the column. So this must be 3 and 6 doubled, which makes this 5, 6 in value with 7 here. That eliminates 7 in the rest of the column. We also don't have 2 available in the rest of this column. 3, 6 eliminates 3, 6 in the rest of the column. 5 eliminates 5 in the rest of the box. 3, 4 eliminates 3, 4 here. 6 eliminates 6 here. We don't know which one of these is 3 or 6. 5 eliminates 5 in the rest of the row. 2 eliminates 2 in the rest of the column. 5 eliminates 5 in the rest of the column. 4 eliminates 4 in the rest of the column. And 3 eliminates 3 in the rest of the column. 6 doubled means we do not have 3 or 6 available to be doubled anymore. So this can't be 6, which means one of these is 7, 8, or 9. Okay. 3 and 6 remaining have to be in column 1 in box 4, because we don't have 3, 6 available here. What are the remaining digits actually in box 7? We have 1, 2, 4, 8, and 9. No 1 or 2 here because of 1, 2 in the column. No 4 here because of 4 in the column. Interesting. That eliminates 2 from the doubler in row 3. So one of these 3 is a doubler. Remaining digits in row 3 are 6, 7, 8. Okay. So this is continuously increasing there. This is going down here, then going up here. 7 eliminates 7 in the rest of this row. So this is 8 or 9 here. Remaining digits of box 3 are 1, 6, 7, 8, 9, no 6, 7. Here we have a 1, 8, 9 triplet in row 1 and box 3. That eliminates 1, 8, 9 in the rest of the row, and box. This can't be 9. That leaves this as 3, 4, 5. And then this must be 1, 2, or 9 available. Okay, so let's double check these. 2, 7, 6, or 2, 7, 12 in value, that works, and 2, 5, 1, that goes up then down, that works. 7, 8, 9 in value, that works. 12, 3, 4, that goes down then up, that's fine. 5, 8, 3 goes up then down. 1, 9, 4 goes up then down. 3, 4, and 5, that works there. 6, 7, down to 4, up to 6, 7, that works. We don't know about this one. These are 4 and 4, so that's going to work naturally there. 8 and 9 is greater than 6, 7, which is greater than 5, so that's going to work there. All of these are going to work because, well, unless it's doubled in value. We have, so that's 3, 6, 7. So this can never be 8, 9 because that would be decreasing it all the way there. So this must be 1. So this has to be 1, which means this can't be 1 there. That means this can't be 8 because that would force this to be 9 and we'd be increasing going that way, but we have no arrow. So this must be 9, then 8 there. So that's satisfied for both this way. It's increasing to the 9, but decreasing to the 8. It's increasing to the 6, 7, decreasing to the 3. 4 and 4 in value means that that's not going to be strictly increasing or decreasing. 8 eliminates 8 in the rest of the column. 9 eliminates 9 in the rest of the column, so this is 8, which means this cannot be 8 here. 8 also eliminated there. And 4 is not 5 or more away from 8, so this is 3, which makes that 2, which makes that 1. 8 eliminates 8 in the rest of the column here. Or sorry, row here. So 3 and 8, so this is satisfied. 3 eliminates 3 in the rest of the box, so this is 6, that's 9, which makes that 7. That leaves just 4 and 5 remaining in the rest of the box, but these do not have an arrow, so this must be 5 here and then 4 here. So 1, 6, 9, it is increasing. 6, then 5, then 8. It decreases to the 5 and increases to the 8, so that's satisfied there. 14, 3, 8, and 14 is 5 away, and it's increasing constantly that way. 14 down to 4, up to 9 is valid, and 4 up to 5 down to 2 is valid. So that eliminates 7 here, so it's 6, which makes that 7. The remaining digits in column 9 are 2, 5, and 8. And 5 cannot be on the Whisper 5 line because these two digits, none of them are doubled. And 5 can never be on the Whisper 5 line in normal situations. That also eliminates 2, 5, and 8 in the rest of the box. We have actually remaining digits in column 8, which are 1, 3, and 7. And remaining digits in column 7, which are 4, 6, and 9. So we have 7 double. Okay, 6 eliminates 6 here, so that's 3, which makes this 6. 3 is the doubled value, so 6 is the normal one. That eliminates doublers in row 7. 2 is eliminated here because of the 2 in the row. We have 5, 6 in value, 7 in value, so that's valid there. Remaining digits of row 7, we have 2, 4, and 8 available. So 3 and 1 are 5 or more away from 8. 7 is 5 or more away from 2, but the problem is, I guess you could have 9 doubled. So that is potentially possible. You could also have 4 doubled here. So that could still work. This must be increasing going this way. So this cannot be 8 here, because that's greater than all of those digits. So it must be greater than that. So it's 3 or 7. And then it must be increasing to there. 4 eliminates 4 in the rest of the row 8 here. So this is 8 or 9. It's decreasing from the 8, 9 to the 6, so it must be increasing back here because there's no arrow next to it. So this cannot ever be 1. This becomes an 8, 9 pair. That eliminates 8 and 9 in the rest of the box. So this can't be 8 or 9. It's 4. So this is valid. This is valid because these are the same values. This is valid going 4 up to 8, 9 down to 7. So this can't be 4 and this can't be 9. If we try to go 4, 2, then 1, that would be continuously decreasing. So that's not allowed, so this must be 1. That's 2 there. That eliminates 1 in the rest of the column. 2 eliminates 2 here, so that's 1. That eliminates 1 in the rest of that row. So where's 1 in column 8? It has to be here. And 2 is not 5 or more away from 8. So this, 2 is not 5 or more away from 1. So this is 8. That means this can't be 8 here. So 4, 1, 2 is satisfied. 4 up to 8, 9 down to 7 is satisfied. 2 up to 8, 9 down to 5 is satisfied. So those are good. We don't have any more 4s in column 1. We have no 2, 4, 5. We have just 7, 8, 9 remaining in column 3. 8 eliminates 8 in the rest of that row. The rest of row 9 is 5, 6, and 9. The rest of row 8 is 1, 3, and 7. So the 1 is doubled here because 3 and 7 already have a doubler. So we have the 1 doubled here. We have the 2 doubled, we have the 1 doubled, so we have the 9 doubled here. That's interesting. So we have the 9 doubled, the 2 doubled, the 3 doubled, the 1 doubled, and the 7 doubled. 3 and 6 are already doubled here. And 9 is already doubled here. So 6 and 3 are both doubled, so they cannot be the doubler. 9 is already doubled here because we already have 1 doubled here and 2 doubled here. So that leaves 8 as the doubled value here, which means 8 has to appear in one of these cells. Cannot be here, so that's not the doubler. So 8 has to be one of the doublers here, which means this can't be 8. It's 9, which makes that 8. So no 8's there. 7, 9 as a pair. So we have 8 as the doubled here. There's no more 9 available because of 9 in the column. So this is 3, 6, 8. No 8 there. 8 is doubled. 4, 6, or 9. We already have 9 doubled and 6 doubled, so this must be 4 doubled. That leaves just the 5 to be doubled in box 5. Okay. That would be a 10 in value. This must be increasing there. We have 8 down to 3 or 7. It must go back up, which it... Huh. So this is consistently increasing here. This must be increasing here. So this goes down to the 1 and back up to the 4, 6, or 9. So that's already valid. 9 is going to be doubled here. So that's satisfied. The 4 is doubled. So the values here are 6, 8, and 9. Okay. This is consistently increasing. So this cannot be the 1 doubled, because if this is 1 doubled, this is at most 2 here. So this is not doubled there. It's 2. It can't be 8 here because that's too big. So those are fine. One of these is doubled. Let's just double check anyways. We have 2, 7, 12. 2 up to 5 down to 1. 7, 8, 9 going up. 12 down to 3 up to 4. 5 up to 8 down to 3. 1 up to 9 down to 4. 5, 7, 8 going up. 9 down to 4. Stay even at 4. 1 up to 9 down to 8, so that's satisfied. 1 down to up to 6 down to 3. 6 down to 4 up to 7. 3 up to 4 up to 5, and that's satisfied. Haven't done that. This is 2 or 5 down to 1 up to 6, 8, or 9. So that's going to be fine. 9 down to 6 down to 1, so that's satisfied there. 4 up to 5 down to 2, no arrow. 14 down to 8 down to 3, that's satisfied. 14 down to 4 up to 9, that's satisfied. 8 down to 5 up to 6, that's satisfied. 3 down to 2 down 1. That's not quite done here. These aren't done yet. 2 up to 8 down to 5, that's satisfied. 1 up to 6 stays at 6, satisfied. 4 down to 1 up to 2. 4 up to 9 down to 7. 9 down to 6 up to 8. 7 down to 6 down to 5, so that's satisfied. Okay, so all those are done. We just need to figure these portions out. It's gonna be a little hairy. We know this is 8 doubled. That's 16. So 4 could very well work with that. This can't... It could be 3 if this is 2. Hmm. Let's see. 6, 8, and 9 in value. So that's always going to work for that. That's always going to work for that. Obviously, if this were 6 in value, this cannot be 7 because then that would be decreasing going that way. Oh, But if this is 6 here, that would force this to be 3, and that would eliminate all possibilities for that cell here. So this can never be 6 here. It's 4 or 9, which means 6 has to be one of these two. So this is always going to be greater than 3 or 7. Right? 8 and 9 in value is always going to be greater than 3 or 7, and 8 goes down to 3 or 7 there, so that's satisfied. This has to be continuously increasing. So somewhere 5 is doubled here. We don't know which. Unfortunately, this isn't very much help because the values are 1, 2, and 18. So it's going to go down to 1 or 2 and then back up to 6, 7, or 8. Or it's going to go up to 18 and back down to 6, 7, or 8. So that's satisfied. Um... Hmm. How do these interact? If you had 5 here, doubled, you have to have 9 and 8 with it. But that seems perfectly fine. It's not, like, very restrictive there. Um... Okay, what are the possibilities here? So say we had 3 here, that's 2. That would make that 7, which would make that 3. So then this would have to be 2. 2 eliminates 2 there, so it's 4, that's 5. 4 can only be 5 or more away from 9 out of 7 or 9, so that's 9 and 7. We can't have 6 normally, so this must be 8 doubled. That would force this to be 6. So this would be the doubler. It cannot be 9. It cannot be the 4 because the 4 is the doubled. So this would be 4 here. This would be 5. We'd have 1 here. No 4, 6. That's 9, which makes that 6 there. So that works there. 8, 7, 8, 2, 3, 6, 8, 16, 5, and 9. 6, 4, and 7. So that all works. So can we do the other way? Where this is 2. This is 2, this becomes 5, that's 2. Oh, either way, so, well, we don't have that being 2. Let's try that being 2. So if we have 2 there, that's 5, that's 2. Which makes that 4. Again, that's 9 and 7. This must be greater than 5, so it has to be 7, which forces this to be 4 or 9 here. That forces 6 to be there. And a 2 or 4 there, so this must be 5. That must be 1, 5, and 6 here. That requires 3 or 8 here. And 3 obviously doesn't work, so this must be 8 doubled. That's 3. This is the doubler, so this can't be the doubler, which makes that 9, which makes that Oh, and that's a contradiction. Okay. So we know this cannot be 2. So one of these is 2. Either way, if this is 2, that forces this to be 4, 9, with the 8 doubled. So this can't be 4 or 9, because the doubler would be 4, so that's 6, that's 3, that's 2. And if this is 2, this is 5, which forces this to be 2. So either way, this is 2, which makes that 5. That eliminates 5 here, so these cannot be the doublers, because 5 is doubled in box 5. So can this be 2 is the question. It looked like this being 2 was fine. It actually worked okay. So can this actually be 2? If we have 2, this can't be 2 here, so this must be increasing going to here, so it'd be 6. Ah, which means this is 3 and 8. 2 and 3 are not going to be 5 apart from each other, so this is always going to have to be 8 doubled, no matter what. So this is always going to have to be the doubler, and it's always going to be 8. That eliminates 8 here. This can't be doubler here. And this can't be doubler here in the rest of this row. So where's a doubler in row 5? It has to be here. So this is doubler here. This is not doubler. So this is 4 doubled. That's 9, and this is 6. This to be increasing, this must be 2, 3, and 6, and this must be 8, 7, and 9. So that's satisfied. This is satisfied, as I said. 16 down to 4, 5, up to 7 or 9 is satisfied. 4 eliminates 4 here, so this is a 2. That eliminates 2 here. This is increasing from 1 to 4, 5, and it must increase to here, so that must be 6, which makes that 3. So now this is satisfied. That's always 1 going down from 6 to 4, 5, down to 1. Goes down from 3 to 2, up to 7, 9, so that's satisfied. 16 down to 4, 5, up to 7 or 9 is satisfied also. So 5 is one of these, which means this can't be 5. It's 4, which makes that 5. Okay. Remaining digits in row 4. We have 2, 3, and 5. Okay. Remaining digits in row 5. We have 6, 7, 8, 9. Remaining digits in row 6. We have 1, 7, 1, 4, 7, 8, 9. 2 and 3 are not going to be consecutive with 6, 7, 8, or 9 as a 3-length rim band. Therefore, we do have to have 5 doubled here with 8 and 9. Because 2 and 3 can only form a 3-length rim band up to 5, which we don't have. So then this must be 5 doubled, which means the rest of them are not doubled. This is not doubled. This is an 8, 9 pair here. And this can't be 8 because of 8 in the row. So this must be 9 here, and this is 8 to be a run band. 9 eliminates 9 here, so it's 7 and 9. That eliminates 8 and 9 here. And this can't be 7 or 9 here, so it's 1, 4. 5 is eliminated here. So this cannot be 9 here because that's doubled. 5 eliminates 5 here. 5 eliminates 5 there. These are all valid, no matter what. So that's all going to be the same. We have a 1, 2, 4 triplet in column 6, which eliminates 1, 2, 4 in the rest of the column. So this can't be 4, it's 3. That means this can't be 3, it's 7. That eliminates 7 here, so that's a 1, 3 as a pair. 7 eliminates 7 here, so it's 6, which makes this 7. 6 and 7 eliminates 6 and 7 here, so it's 8. 6 eliminates 6 here, so it's 9. So that's going to be satisfied no matter what. 9 eliminates 9 in the rest of the row. 8 eliminates 8 here, so where is 8 in row 7? It must be here. No 7 or 8 here, it's 6. And no 6 or 8 here, it's 7. 3 eliminates 3 in the rest of the row. What do we have? We have a 1, 2, 3, 4 quadruplet in column 5, which eliminates 1, 2, 3, 4 in the rest of the column. So no 1, 2 here, it's 9. No 4 here, it's 5, which makes that not 5. It's 6, which makes that not 6. It's 5. That eliminates 5 there, so it's 4. No 9 here. So this is not the doubler. The 9 must be doubled. So we have this, no matter what, is going to be 2 or 3 in value. It's going to go down to 2 or 3. Okay, so that might be... So if this... Okay. This is not doubler, so this cannot be doubler, which means this is doubler here and must be the 1. That leaves this as 3. 1 eliminates 1 here, so it's 2, which eliminates 2 here, so it's 3, which eliminates 3 here, so it's 2. 2 eliminates 2 here, so it's 4, which makes that 2. That makes that a 1. And let's just check this. 6 down to 3, up to 4. 5 down to 2, up to 8. So those are satisfied also. And we can just fill everything else out. So that's 4, and that's 1. Pretty cool, actually. I wasn't sure about the logic here, but it was a very interesting exercise in how these turned out. Yeah, it was nice. It was an interesting logic between these Renban lines and the negative. It's essentially a negative constraint about the direction of the arrows, too. So that was a lot of information there. But also just a lot of the information like here was interesting too. Yeah, very, very cool puzzle. Nice puzzle. I'm not sure why it's called Nightingale though. Not sure what it's referencing there. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.